Welcome to Everything EOS. Get ready to dive into the constantly evolving world of Web3 and join us as we explore the game-changing ideas and technologies that are powering a renaissance of GameFi, DeFi, DAOs, NFTs, and more on EOS. Today, we are going to discuss the latest developments with EOS EVM, the Ethereum virtual machine deploying on EOS. I'm your host, Brandon Lovejoy. My co-host today is Zack Gall. Zack is co-founder and chief communications officer of the EOS Network Foundation and originator of the Everything EOS podcast. And to help us get into all the details, we are joined by two other esteemed guests, Areg Hayrapetian, director of engineering at the EOS Network Foundation, a core contributor to the EOS codebase since before launch of the EOS mainnet. Alongside his work with ENF Engineering, recently Areg has been supporting the Origin team with their work on Antelope IBC, the forthcoming instant Finality, and working alongside Matias Romeo on EOS EVM. And last but not least, the newest member of the ENF Engineering team, but certainly not new to the EOS community, Matias Romeo. Matias is a longtime EOS contributor, a founding member of the block producer team EOS Argentina. Matias helped launch the EOS mainnet. Among his many contributions to the EOS ecosystem, after the launch of EOS, Matias developed a smart contract that helped restore over 3 million frozen EOS tokens to their rightful owners. He cooperated with Bitfinex in the development of the EOS Finex on-chain exchange. Matias was also lead blockchain developer of LACchain, the Latin American and Caribbean chain testnet for the Inter-American Development Bank, and co-organized the EOS Rio conference in Brazil. And not least of all, Matias was instrumental in integrating MetaMask to EOS mainnet. If you like what we're up to here on Everything EOS, remember to hit that like button and subscribe to our channel to stay in the know about the latest on EOS. So let's get to it. Thanks everyone for being here today.
Got some legends, man. Holy crap! On the resumes, I knew these guys were good, but man, whenever you lay it all out like that, woo!
I know.
I think, but Matias, you were a core contributor to EOS. Was it before the mainnet? I saw you had some code contributions.
Yes. Before joining the EOS Argentina team, I previously worked at Block One for 1 year, together with Areg, doing contributions to the development of EOS at the very, very beginning. Yeah. So in fact, I also remember Areg from previous days from BitShares also, and also for the Steam. So yeah, we kind of old timers in the EOS ecosystem.
All three of you guys are old timers and following the Dan train all the way from BitShares.
As I remember, right, and also yeah.
Escape back in those days.
Right. I remember. It's been like I don't know. It's 8 years. I can't remember, but 7 to 8 years, right? Like time goes by. Like
kind of scary.
Yeah.
Wow. So I think this is the first formal announcement that Matias has joined the ENF as part of our engineering team. So that's the announcement.
Welcome to the ENF.
It's been great. We've been working with them since the very beginning almost of the ENF. So we announced the EVM Plus working group in January of 2021. So that's when the formal working relationship with Matias and the ENF kind of began. How did it, in your memory, how do you recollect like this whole initiative getting started? Did you pitch the EVM to the ENF, or did the ENF kind of come to you?
Well, we as a team with my group with EOS Argentina, we always were looking for ways to make EOS more accessible or more. In fact, it's friendly for us. It's friendly, right? But we were looking for ways to improve the platform, and one of the things that we started with was the integration with MetaMask. But the integration with MetaMask was just a way to use EOS without installing any new wallet, just using your regular MetaMask wallet, just point to a new chain, and that's it. But you can interact with the EOS runtime using MetaMask, right? It wasn't a EVM runtime. You're just using the EOS runtime with MetaMask. So after that, we were presented with the opportunity to contribute to one of the blue papers, and we say that we were not sure that we can contribute something meaningful to those documents, and we told EOS that our next work will be start working in an implementation of the EVM. And then I said, well, why don't we formalize this and see if there's a way to work together? Why don't you talk with your team if they want to start doing that? And so there we started. Yes, that was January 2021, right? You were mentioning.
Yeah, I think it contract was probably closed. We announced it in January, so this probably all happened in November, December. So that was kind of the idea at the very beginning, was getting all of the blue papers written, the Core Plus, Audit Plus, API Plus, and Wallet Plus, and then EVM Plus was the fifth one. But instead of writing a paper, you were like, I'd rather just build, and that's what happened.
Yeah, because
skip the paper, let's just build something cool.
By the time I finished writing about it, we could have built it. Yeah.
Yeah, the specifications are there, right? It's not that much that you can write on an EVM Plus paper. So we thought that the real stuff was to have something running and have something like on chain for developers to test. The thing is that, well, we can go on details later, but yeah.
Yeah, so yeah, we can get into it. I'm really excited to have this discussion, and I'm really glad Zack is here to help bridge the gap between some of the deeper technical nuance and myself. I'm kind of a noob when it comes to the EVM and everything, so I'll be here to ask the questions that need asking. And today is a kind of a significant date because today the ENF announced the launch date. And so we've got an EVM launch roadmap. Maybe y'all could walk us through the roadmap. Looks like there's a code complete, a new testnet launch March 27th, followed by security audit, and then mainnet beta on April 14th. Areg, you want to take us through what that's going to look like?
I mean, I'm not sure how much more I can add to that. So the 2 dates you mentioned are just here is the testnet launch March 27th, and then the actual beta launch for mainnet. The testnet launch, compared to the existing testnet that exists on Jungle 4, this will also be on Jungle 4. Introduces the new token economy changes to the EVM runtime, so we can get into that in a lot more detail. So that's exciting. I don't know what else to add for the actual main event.
I'll handle this one.
I'm glad to see it, but I wrote a question. I'll handle it.
Essentially, code completion, that should be happening very soon. All of the final touches are being made to the code that were not implemented on the previous Jungle 4 testnet launch, which we announced in January. So the final code will be out first. That'll be the first step. From there, we're going to deploy it on Jungle testnet. It's going to be deployed in parallel to the previous testnet to allow dApps time to migrate over if they don't want to lose their data. And then the audit's pretty self-explanatory. Once the code's complete, we give it to the team at Sentinel. They're a contracted auditing firm. They did a great job auditing the Telos EVM. They've already audited the EOS EVM also, but we've made some significant changes, and then the Silkworm implementation. So this is their second audit for the EOS EVM. And pending any major bugs or anything that they may come up with, we have a target testnet launch date, late March, and then mainnet beta launch for the EOS EVM on April 14th. So this has been a very long time coming. It was just announced today. We're recording this on February 28th. We've been itching to get an actual date out for so long because we don't want to put a date out there and miss it. So it's really just syncing up with the product managers, the project managers, the engineers, marketing and just really making sure that all of our ducks were in a row. And we finally have this date of April 14th. So I'm super excited that we finally have a target. We're 6 weeks from launch, maybe 5 weeks by the time you're watching this. But we're executing it within a year of the very first testnet launch. The first testnet pre-Silkworm, pre a lot of things happened on April 19th, 2021. So it's great to see that we were able to execute the launch prior to that. But to get into one of the major changes with the previous testnet to the new testnet is the gas economy. So one of the biggest shifts that we announced in the January update to what was previously called the Trust EVM project was we removed the introduction of an external token, and we're EOS is the native token, EOS is the gas token. There was a different economy planned. We won't really get into that today, but we'll get into the economy that you're going to see on this next testnet release. Areg, you want to kind of explain what the gas economy is and how the EOS token is being leveraged under this new model?
Sure. So the EVM runtime has a native token, right? If this is the EVM running on Ethereum, this would be ETH. Other forks of it that run the EVM need to come up with their own token, or maybe they end up using ETH or something else. You need some sort of token as a native token to pay for the gas, to just make the whole thing work. So initially, as you mentioned, prior to the switch to using EOS as the native/gas token, there was another new token to be introduced for that purpose. Now we've made this shift to just use EOS itself. And what that really means is internally, we still have a new token. I mean, it's not a new token. Internally, we have a representation of a token that's compliant with what you'd expect with the EVM, with Ethereum, right? We have 18 decimal places, but it's one-to-one matching EOS. So you bring your EOS in from the outside, it mints the appropriate amount of that EOS internally inside the EVM environment, essentially. And then you hold that in your EVM accounts, and you can transfer those as you do, or you can use them with contracts, do message calls to contracts. And then eventually you want to be able to pull out those EOS tokens out from that environment to the external environment being the EOS side of things, where now it's being held by your EOS accounts. So we've made that change to use the EOS token. We've introduced this trustless bridge as a mechanism for the ingress and egress to get the tokens in and out of this internal environment. And the native token is also necessarily the gas token. It's how you pay your gas. So there's this whole other mechanism. We can go into a little more detail about how that gas is paid, but not just paid internally in the internal EVM environment, but how that moves essentially across that bridge to the outside, where it's then used to kind of split into two streams to be diverted to one, the EOS account that's paying for the CPU and net resources of that Antelope transaction, EOS transaction that runs within it the EVM transaction, and two, another stream of the EOS funds, which are used to cover, one, RAM costs of the contract. That's the third EOS resource cost that needs to be paid for, but also other costs and potentially burning as well, right, which you can get into a little bit later. There's that whole token economy model of like, how do we get from the gas that's spent in the EVM model out to the outside, where it's then properly distributed and handled.
I think that was one of the biggest points of confusion that we were able to eliminate by just going all in on native EOS is, regardless of what you call the token on the inside of the EVM, underneath it all, EOS resources are being leveraged. Transactions on EVM are using EOS CPU on native, whether you have a new token or not. But I think this is a very good way to add brand new utility to the EOS token, and also an opportunity to create a burn mechanism with this new gas model. So it's in previous communications, it's been mentioned that there are plans to for the RPC node that the ENF will be operating, all of the revenue generated above and beyond the resource costs, which would be your RAM and CPU, the rest of the EOS is essentially going to be burned on a periodic basis, and we'll be announcing those burns and probably have a fun little indicator on a front end somewhere that shows how much gas has been burned or is in the burn account ready to be burned at the next burn, for example. So I'm really excited to have that model as part of EOS. Since the network launched, a lot of other chains and projects we've seen introducing different deflationary models to offset token inflation. And obviously with EOS, like the node operations and the ENF itself is funded through an inflationary mechanism. So the better we can do at coming up with two things: one, models to burn EOS where it makes sense, and other models where you could share revenue back to EOS token holders in REX, for example, where when people trade RAM, there's a 0.5% transaction fee. That fee gets fed to REX stakers as yield. So you have those two options. Would it be better to burn something and remove it from circulation, or pay it back to token holders who did some action such as staking into REX? So that's something like I'm constantly thinking about. So I'm really excited that in the fall, when we announced EOS Network Ventures, that was the first, I guess, opportunity at a burn mechanism. So with EOS Network Ventures, the idea is it'll make investment in for-profit projects, so that basically any profit realized on these investments after however long it takes to realize those profits, 2, 3, 4, 5 years, the proceeds will actually be used to buy back EOS and then to burn it. So that's the first burn mechanism. It's an off-chain mechanism by the time it actually occurs, because typically VC investments are longer term. It may be automated by that time or enforced on chain. It hasn't really been decided, but this process with the gas model on the EVM, it'll be most likely programmatic with scheduled burns that we'll be able to kind of announce in advance and create kind of an announcement out of, so to speak. So it'll maybe quarterly. This is all kind of TBD, but to conclude on this ramble, the more ways we could burn EOS, the better, and the more ways that we can generate yield in some ways for EOS token holders. And a lot of times we don't even need to even worry about how the yield is generated, because we have programs in place such as Yield Plus, which allows the DeFi protocols to figure out how to earn the yield, and we'll just kind of subsidize it.
So I speaking of Yield Plus, I mean, I'm really excited with this change to using EOS as the native token, and there's like two aspects of it that I think are interesting to me. One is it really simplifies things, because the truth is that the previous model, where it was a separate token, you still pay for the EOS cost. Like, you can't avoid that, and that's the beauty of it. This is running on EOS, so no matter what this internal system decides to do for its token economics, the fact that it's running on EOS means it has to pay for the EOS costs, CPU, net. You can't avoid it. So somehow the money has to work out. It was just a very convoluted mechanism where you have to convert this new token to EOS to then pay for the RAM or pay for the power-ups or whatever. Now it's a lot simpler. It's easier to understand. There's less steps of conversion. So that's one aspect. But the other aspect is, again, simplification, but it's also like the EOS can now just be used inside of the EVM in the contracts. Like, the total value locked, like, that's EOS now, not some new token.
Yeah, the amount of times that we had to explain to people how you're still using EOS underneath it all, it's just this conversation that had to happen over and over and over again, that it does simplify things significantly. There were a lot of reasons for an ecosystem token. For example, ecosystem grants dedicated to the EVM, for example, whereas now we're leveraging the existing programs that we've already built in the EOS ecosystem. That's the direct grant framework, Pomelo, and direct contracts, even depending on the project or partnership that may come up. But it'll essentially just use the mechanisms that we already had, whereas if it had its own token, it wouldn't be necessarily using EOS to incentivize people to build on the EVM, which is a different runtime than native EOS. But I think for simplicity's sake, for putting all eyes and attention on EOS, that this was the right direction. And I'm glad it took a little bit of time, but I'm glad this is the direction we went. I'm glad this is the the way we're going to be launching the mainnet beta. You brought up Yield Plus, and I wanted to use this particular conversation we're having now to clarify certain things of what will and will not be live on April 14th when the mainnet beta launches. And one of the things that I want to be clear on is the functionality of the Trustless EOS and EVM bridge. So, Areg, I think you're probably the one who's been working on that more. Do you want to explain like what the functionality is, what you can and cannot do at launch?
Sure. So this is actually related to the simplification discussion as well. So at a technical level, this trustless bridge works only with the native token, which previously was another token. Now it's just EOS. The mechanism we use is it's fundamentally only working with that native token. We have thought about other ways to expand that to newer other tokens. That requires going beyond the native token, supporting some standard like ERC20, wrapping EOS assets, new tokens on the EOS, other tokens on the EOS side in some sort of ERC20 compatible way to move them across to the EVM side. So this is all a couple applications we've thought about, but just in the interest of just to get out, the functioning EVM runtime for mainnet, we focused on just the critical function of supporting the native token only for now. This is actually already an improvement by going to the EOS one, because if it wasn't that, EOS would then have to be treated like a ERC20. And so MVP launch would only support EVM, and we'd have to figure out EOS as a fast follow. Now it's using EOS as the gas token and the native token. We get it for free, and we don't have to worry about other tokens. But obviously, there are still other tokens like, USDT, for example, or USDC, other tokens that people are going to be interested to move in and out of this environment. And so that will not be available as part of this MVP version of the Trustless Bridge, as part of the initial beta launch, April 14th version of the Trustless Bridge. That will have to come later. Some of the complications there, obviously the biggest complication is handling the fact that there are different token standards. We don't, on EOS, we have this quasi standard of ESI token with, CDT's asset type has certain limitations. It can't represent the same 256 bits of amounts that you can in the EVM side. So you need to account for that. There's the ERC20 standard on Ethereum. You'd have to somehow wrap things. So there's things to figure out in terms of maintaining compatibility between what's expected on the EVM side and what's expected on the EOS side. There's other things to figure out about the exact mechanism of how you cross the bridge, or you cross that bridge. One thing to point out is this trustless bridge alone requires some changes to the internal protocol of the EVM. They're very minor changes, and we've worked very hard to maintain as much compatibility as possible. We could talk about that a little bit more in various different contexts, but there are slight deviations we've done to achieve what we want to do with EOS EVM. One of these is to facilitate this trustless bridge and to make it trustless, to make it core to this contract and not require some third party to act as the bridge. So it's not trivial to add support for new things. We're going to think about it very carefully, because we do want to ideally support in this similar trustless way.
Matias, anything you want to add to that?
I got something in my mind, but it just went away. But yeah, one thing to mention is that even if the trustless bridge won't be available when we launch on mainnet, as Areg was mentioning, that also a third party can act as an oracle on both runtimes and take tokens from one side and issue it on the other side. So also, I don't know if any any member of the community or company can make that work also. But yes, we plan on working on the trustless mode beyond the release.
Cool. I don't know if I dare pull us out of the weeds, but I might have to pull us out of the weeds just temporarily here. Can we just back up a second? And I know we launched right into some of the deeper mechanics and like the riveting details of how this is implemented. I just want to ask if Areg or Matias, you want to take a stab at just explaining why is it important for EOS to have EVM? And yeah, let's start there.
Okay, I think I can take that one. Well, whether we like it or not, I think that the EVM it's now a de facto standard across the whole ecosystem. So that's one part of the things of what I think. And the other one is that we have a excellent layer one already running for many years with great performance, right? So there's already a big ecosystem of developers, tools, auditors that works on top of this runtime that's the EVM, right? Plenty of documentation. So it's really friendly for developers. So and we have an excellent layer one runtime on EOS. So I think that it was a no-brainer to have support for that runtime on top of EOS, and because we want to be as compatible as possible. That's what Areg was mentioning, that we don't want to deviate from the standard much. That's why also we took some other decisions that maybe we will be talking later. But yes, I think that it's a standard. There's plenty of developers already trained in Solidity. There's a lot of companies that do audits, smart contracts on that runtime. There's a pretty big ecosystem out there. So I think it was a no-brainer to support that on EOS, knowing that our layer one performance is excellent, right?
It's a bigger risk to not have EVM at this point because EVM has become a standard. It's got a very robust tool set, testing frameworks, open source code, and libraries to be pulled from things like OpenZeppelin. And all of that's already taken care of. As the ENF, we don't need to worry about any of the developer tooling. We just need to provide the base functionality of an EVM runtime and allow Solidity developers to be able to expand their applications to EOS or just build it there from the beginning on the EVM. Without having the EVM, a lot of doors were shut. It was impossible to partner with certain projects or to collaborate in any way, because once you build on a certain technology, to be able to go multi-chain onto other technologies. So if you build your project initially in Solidity and then you want to expand to EOS, and if native is the only thing available, that's a whole code rewrite. You're rewriting it from scratch into C++ to compile to WASM on EOS. So by allowing them to develop, they as in developers or projects, to allow them to just take the smart contracts they're already using or the smart contracts that already exist in an open source library somewhere, to be able to just bring those to EOS and deploy them immediately, not worry about what tooling EOS native has or doesn't have, don't have to worry about the EOS resource model being different. They work with all of the tools, all of the gas models that they're already comfortable with, and end users as well. They're already comfortable with paying gas, they're already comfortable with MetaMask wallet, basically opening a door that was previously not open for years. So in my opinion, it was just a huge, huge risk to not have that. And now we have that functionality moving forward, and we can continue to focus on building up native EOS as a standard, because it's not like that's going away. Native EOS is going to be and is the priority. As we launch the EVM, we're rolling some of our ENF engineers off. So Areg as an example, because he will be refocusing more of his time on native EOS. And that's why we've internalized some of the engineering with someone like Matias, who he will be focusing on the EVM internally. So it allows us to do both. I think for native EOS, the business opportunities are better for introducing like Web 2 companies to enter Web 3 for the first time, because then they don't have all of this technical debt in Solidity or things that they need to rebuild. They're just building it from scratch and using native EOS from the first place. But if we're talking about like what exists today in the Web3 space from end users and developers, meet them where they're already at. Like it's a lot less friction to let them use the tools and technology and everything that they're already used to, rather than trying to force feed them something that they're unfamiliar with. So when we talk about EVMs, we're almost exclusively talking about Solidity developers, because Solidity is the native language of the EVM. But one of the most recent features added to the not this upcoming testnet, but the last new testnet, the one that launched in January, the new functionality that was added to the EOS EVM was Silkworm. And Silkworm just happens to be a C++ implementation of the Ethereum protocol. So I've had a lot of questions of people like wanting, what is Silkworm? Why is it important? Why did we choose to migrate from it? This is really loaded. Why didn't we just choose it from the beginning? So yeah, Silkworm is the question. Have the floor.
Okay. I think I can answer some of the questions there. But yeah, well, the thing is that having EVM support for EOS is not only about the runtime, right? We implemented the runtime in regular EOS smart contract, and where the EVM is running there, but that's only one part of the project. In fact, it's one part of the overall experience, because developers need a way to access the change data, right? The EVM data. They need a way to submit transactions. They need a way to query the blockchain, right? You also need block explorers to extract information from this runtime to generate the website for developers to explore. So the execution part, the runtime, is one part of the project, but the other one was to build an compatible RPC, right? Full compatible RPC for the EVM. So there was a C++ node in the Ethereum ecosystem named Aleph that is discontinued right now, but some time ago, I don't remember exactly when, there's come up a new specification for a node that is named Erigon, which is thinking in terms of efficiency. And one of the implementations, it's based on C++, which is Silkworm implementation. So basically, Silkworm is an Ethereum node under the specification of Erigon that we are using to support the RPC compatibility. Basically, we execute the transaction inside the EOS smart contract, and then we extract that transaction using the state history plugin, and re-execute that transaction outside Node EOS, and we using the internal Silkworm libraries to generate a database that's accessible to the RPC node to serve the request. So basically, we are building a blockchain database in under the Silkworm specification to serve the RPC request. So that is basically what 90% of the Silkworm code is being used. I don't know if Areg, you want to add something, but yeah.
I mean, I guess I'll just add that, like we're leveraging this existing code in the Ethereum space to provide this critical functionality of the RPC. We're also, where Silkworm comes in specifically, rather than what about alternative implementations of EVM and Ethereum nodes, is we do share a lot of that core code, the execution processor, in the two environments. And that's really handy, especially as we make some tweaks to support the token economy. We know we're running the exact same code. This is critical. We're basically re-executing the logic. We have to be re-executing logic identically in two different environments. The first is the contract, and the second is this EVM node, this thing that generates the database that feeds the Silkworm Silk RPC service. And the whole point there is we leverage that existing tooling and the ability for us to scale that to meet the ETH RPC requests of users in a compatible way, exactly as they expect. And still make that, whatever that changes are, work with a contract, which requires us to build that in C++ to compile it to WASM to run on the EOS blockchain. I mean, I guess technically you could use Rust too, but the tooling and contract development toolkit CDT supports C++ right now. So that's part of the other constraints of what we were looking for, is something that was implemented in C++ so it could use in these two very different environments.
I think a common theme there's been with the EVM is to squeeze as much performance out of the EOS EVM as possible. And the transition to Silkworm, which happened sometime in the fall and was one of the reasons for the timelines shifting a little bit, was to implement Silkworm to squeeze the extra compatibility and performance out of it. But then there's other functionality that's actually included in the hard fork that we had in September with the release of Leap 3.1. We're now on 3.2. There was a function called crypto primitives, and it added new functionality that was critical to the EOS EVM. Do either of you guys want to take a stab at explaining that one?
Areg, please. Go ahead.
Sure. Well, I do want to wrap up one point of what you said before we move on to that one, because you did mention performance, and before we had this additional service written in JavaScript to do translation from the blockchain stream, basically all the push transactions, first push TX actions that are happening for the EVM runtime contract and blockchain are being extracted, and then from there constructing a virtual blockchain to be fed into a modified get line. The Silkworm change, we're still on the topic of Silkworm, like that is about speeding things up without bottleneck, right? So now instead of doing that, we're using ship to stream the blocks. The EVM node is in the C++, extracting and processing that very quickly. So there's performance improvements there as well. We still have this concept of virtual blockchain, going back to the idea of we have two different environments executing this code identically. Their communication is this virtual blockchain. In the prior case, that was explicitly created by this translator. Now it's just implicit, but it still exists as a concept. It's actually pretty important to think about, because everything you need to reproduce it in the second environment needs to be captured in that virtual blockchain stream of transactions. And that means you need to actually be careful in the first environment to not use special information that you only have in the contract, like what's happening on the EOS side of things. So it's an interesting constraint that plays into the whole bridging and gas-free stuff that we'll talk about later. I just wanted to kind of wrap that Silkworm discussion up with that. As for the other aspect that you asked about, the
crypto primitives and
crypto primitives, yeah. I can answer that. I don't know if Matias, would you like to?
Yes.
Let me feed into it first. Is essentially functionality, and this was never possible before because the maintainers of the code base weren't really building for the public network, and this functionality was seen as being highly valuable. I think, Matias, you were the one pushing for the pre-compilers originally, weren't you? Yeah. So we were actually able to include, in the Antelope roadmap, we included new functionality to be added that was mainly to benefit the EOS EVM. It probably has other functionality it enables for native EOS, but in the short term, it was specifically added to the 3.1 roadmap to get it as part of the hard fork, specifically to help us launch the EVM.
Right, exactly. Yes, that was one of the first things that we pushed to Antelope was this. Well, the thing is that EOS has this particular way to extend the protocol that you can there's a protocol feature where you can extend the protocol or add new features, and these crypto functions or crypto primitives, I don't remember the name exactly. What it's doing, it's making available new intrinsics to the EOS contracts, right? But in particular, those intrinsics are mapping one-to-one to the Ethereum precompiles. So basically, the Ethereum precompiles is the same that we have on EOS, that we name them intrinsics. It's code that runs on, it's implemented inside the node. It's part of the protocol, but they are not running in EVM code. It's native code. Basically, the contracts can call this precompile. So basically, these new sets of intrinsics are the one being used by the EVM runtime contract. Well, and not only that speed up some of the operations, but also it's part of the compatibility that we aim to have. So yes, I think that was a great addition, not only for the EVM, as you mentioned, Zack. Now developers of EOS contracts can also benefit from using new functions, new intrinsic, new crypto primitives, but it was kind of crucial for the EVM runtime to be 100% compatible and able to run some kind of code.
Yeah, I'll just add to the compatibility part, because I mean, in Ethereum, these precompiles, all of that is just a function. You can implement it. You can implement it in Solidity if you want to. It'd be extremely expensive in gas, and maybe you hit limits. But in theory, you could do it, but in practice, you can't unless it's fast enough. Otherwise, it's just not economically viable. Similar issue exists with EOS, right? There are already host functions we had that you could implement that in WebAssembly, and actually, because it's WebAssembly, it's actually faster, but it's still not fast enough than running it even with our EOS VM backends. It's still not as fast as running it natively on the actual Node.EOS side, the binary compiled binary code running that for you, which is where host functions come in. And for some things, like the AltBN 128 host functions, they're pretty expensive. That if it's not provided as a host function or intrinsic, and you try to implement it yourself, it may cause the contract to run for too long that you start hitting deadline timeouts. And that's where compatibility really comes in, because the EVM contract did support these things without the host functions. It's just when your contract does use those precompiles, it just takes a lot longer, and maybe you're now going to hit the EOS deadline limit, and now a contract you expect to work on Ethereum may not work on EOS because of just time. And that was a big motivation for us to consider adding the host functions, support accelerating those functions in EVM. But also we take that very seriously. Anytime we change the protocol, we're stuck with it forever, basically. So we wanted to make sure it was adding value. We added in a way that adds value, not just to EVM, but for others. And those particular functions I'm talking about, there's others too, like modular exponentiation, which also has value with RSA. Like I think Wax added a host function just for that purpose. But the core part of it here can be satisfied with this modular exponentiation host function. The AltBN 128 host functions not just allow us to accelerate the precompiles expected in the EVM space, but they also, for the same reason, in the Ethereum space, they have ZK SNARK verifiers built on these. We could also, therefore, by making host functions, have them supported outside of EVM in EOS contracts. So that provides value beyond the EVM, where now others can use that to build a ZK verifier, for example. So we saw a lot of value in adding that host function, and decided to go with it with EOS and integrated it in there, and we got into the current one.
I'm looking for a soundbite here. Could you elaborate a little bit? This intrigued me when the 3.1 README came out, the release notes, specifically for the crypto primitives, and you just called it out, ZK SNARKs. So what is the pathway? Like ZK SNARKs are always kind of being talked about and innovated on. It's part of kind of like zero knowledge, like how do I even explain it? It's kind of like being able to prove something without actually showing your cards, essentially. Is it possible to bring ZK SNARKs to EOS or EOS EVM native? And if not, what functionality is needed to get to that point, to have those zero knowledge proofs and being able to prove data without actually showing the data?
Yeah, so there's lots of different implementations of zero knowledge proofs and different ways of doing ZK SNARKs and ZK starts. The one I think is most common because it's available in Ethereum is the ones built on these precompiles, which we now support. So whether you do it through EVM or you do it directly on EOS, you now have the tools to build that verifier directly and take advantage of exactly the same ecosystem of zero knowledge proofs that exist in the Ethereum space, including things like, there's all kinds of use cases there. I mean, the most common ones in that space, I think, are like rollups, ZK rollups for a scaling solution. But I mean, the possibilities are really endless.
So a common word that keeps coming up and is very important to how the EOS EVM was architected is compatibility. I haven't been counting every time I've heard it, but it's a constant theme. Performance and compatibility were two of the key focuses in the roadmap and architecture. So a strategic engineering decision was made sometime in the fall to go from previously half-second blocks, which EOS is fully capable of. It's one of the fastest blockchains out there as a layer 1 with the half-second block speed. The engineering team, you guys essentially made the strategic decision to go with a 1-second block speed. What led to that decision, and how does that factor into compatibility? And maybe just walk everyone through that thought process, because I'm sure this is something I've already seen come up, and we'll probably see more of it as we speak about this block speed more.
Sure. The main driver is compatibility. There is another factor, which is this competition. Okay, so on one hand, we have performance. In this case, it's not throughput. The half second, 1 second doesn't make a difference for throughput. Throughput still take advantage of the raw speed of transactions per second enabled by EOS. So that's not the issue. Performance here, we're talking about is latency. So how long does it take? What really matters is I send my signed EVM transaction out and sign with the MetaMask, and when do I get feedback that it's confirmed on the blockchain? Maybe not irreversible, but at least on there. And then also would be interested in the times of finality too, but that's a whole other discussion involving instant finality if you want to improving that on EOS. But just getting it in the block, for example. So yeah, half-second block times versus 1 second block time. We save, half a second in latency in theory, right? In practice, it's more complicated than that. There's other factors as well. So it's a competition between compatibility and latency performance. There's caveats to how much you gain going from 1 second to half second on the performance side. But what you do lose very clearly is a lot of the compatibility side. And that was the main motivation to go with 1 second, which is the fastest speed you can go without breaking compatibility. So what is the compatibility issue here? Well, Ethereum, EVM inheriting the concepts that kind of the restrictions of Ethereum, right? It's like some of that's part of this EVM spec of what resolution in time a timestamp opcode would return. Some of it is, just there's no resolution. Like a timestamp on an Ethereum block header just doesn't have the resolution EOS does for half seconds, for milliseconds. It's limited to 1 second resolution. So that's just a limitation of that protocol. And so if we wanted to have, let's say, a 1-to-1 block mapping where every EOS block corresponds to this I talked about this virtual blockchain, the EVM blockchain, it corresponds to a virtual block in that space that Silkworm then processes and makes available in the block explorer, saying the virtual EVM block height is X, and that maps to the EOS block height of Y, and the next one is X plus 1 mapping to block Y plus 1, 1-to-1, right? So you get as fast as possible. What's the disadvantage of that? You have two choices. Either you actually you have one choice, I think. You're basically forced to round.
How much choice?
Yeah. Well, you have two choices on rounding, I suppose, but you're basically forced to truncate or round or do some sort of reduction on the timestamp. Because in EOS, you have, say, block a timestamp whenever, so when you have 10.0, and then the next one's 10.5, then the next one's 11. Okay, so you have two blocks, 10.0 and 10.5, that have to map to a whole number. What do? So you end up with two blocks. One is at timestamp 10, the other one's at timestamp 10, next one's at timestamp 11, 12, right? So you duplicate it. What does that do to the expectations of EVM contracts that are written assuming strictly monotonically increasing timestamp? Maybe nothing, but it's a risk. It's a break in expectations in what the contracts expect that could break some things. And the question is it worth it? I remember there's another choice as well, which was unacceptable because of compatibility, which is, okay, you can just add resolution, but then you break the opcode of the timestamp. So that was like, that's not okay. So we could pick the option that does the least damage to compatibility, which is just rounding down, and say that's good enough. But what do we gain out of it? We gain a half-second improvement in latency theoretically, but in practice, you say, oh, that's a 50% reduction in latency. But in practice, it's a lot less than that, because you're not counting the time it takes for your transaction to propagate to the node, the time it takes for it to show up in the block explorer. You add all those, it's not a half second, it's a little bit more. And so the reduction in latency as a relative percentage is actually less. And so there is a call to be made of which one's worth it. Is this, marginal decrease in latency worth a potential break in compatibility in contracts? And we thought it's not worth it and decided to go with the compatible option that's still fast of 1 second.
Right on. Speaking of speed and compatibility, I suppose, to the work you're doing.
Sorry, Brandon. Just one thing to add. What Areg was great explanation, but also what this gives us is a way to decouple both runtimes, right? If EOS in the future want to change the block frequency, that won't impact on the EVM runtime also. So that's also one thing that, in fact, Areg suggested was to decouple the both runtimes in those terms, even if they are highly.
Yeah, thanks for bringing it. I mean, I didn't know if we were going to get this out, but it is interesting. So maybe you could just say a few words on that. What I just said before is about, 1 second resolution. And one way of doing that was to do a 2-to-1 mapping. So you kind of take the transactions of block whatever 100 and block 101, and you build up together into one EVM virtual block, right? So you get 1 second resolution. That was a perfectly viable option too. We went further than that. Once we decided, okay, we're gonna have 1 second timestamp resolution. We didn't just want to do a 2-to-1. Actually, before we started off with 10-to-1, and then we were talking about reducing it down to 1-to-1, and that's what brought up this whole discussion of compatibility. And then we're discussing 2-to-1, but we actually went with a different approach. We went with a time-based approach rather than a block mapping approach. And this gets us what Matias was alluding to just now, which is, let me explain a little background. Maybe Matias, you could add a little bit here, but I think a lot of these contracts are built, again, expectations of contracts. A lot of these are kind of built with the expectation that there's an average time spacing between blocks that is fairly consistent. A lot of them actually rely, even though they care about time, they really rely on block height as a means of inflating new tokens or something like that. And that has some reasons to do with, like, they feel they could trust, the block increments more than the time increments, because technically it's, actually I don't know the reason why, but for whatever reason, it seems like some contracts prefer the block height, even though they're built with the expectation that there's consistency between the time between each consecutive block. And so, like, the EVM space kind of abstracts the underlying EOS layer, and you shouldn't care about the underlying EOS layer. You don't care about the resources of the EOS layer. You don't care about CPU or net or RAM. It's all just gas. It's exactly what EVM contract developers expect. So we didn't want another situation where if we were to decide to change, I'm not saying we're doing this, right? I don't think there's no plan to do this, and I don't think it's going to happen. But if you were to change the underlying block frequency for EOS, let's say you brought it down to 250 milliseconds, or maybe you made it variable as a means of being efficient. Like you could have longer block times or shorter block times depending on dynamic conditions. Those would then change the underlying expectations of contracts of how quickly blocks are generated, the virtual blocks are generated. By switching to time, we can maintain those expectations regardless of what's happening on the underlying EOS blockchain. So that we maintain that abstraction. And again, it comes back to compatibility. Compatibility not technically of the actual protocol here, but of the expectations EVM contract developers have of how blocks work.
When we say compatibility, means if you're a developer, you come from Ethereum, we want this environment to be as similar as possible to Ethereum as it could possibly get. And I believe the engineering team went very far out of their way to make sure that we went the most efficient route towards that compatibility, even though from a comms and marketing standpoint, the block speed is something we've had to explain. And thank you, Areg and Matias, because you guys just created me a nice soundbite to answer the question, because it was very well thought out. There's not a performance decrease. We could benchmark half-second block speed against 1 second block speed, and it's either going to be the same or even slightly better with the 1 second. So if anyone has more questions about that, feel free to ask in the chats. But I think you guys did an excellent job. Thank you very much for articulating that, because it's much better than I could do. Areg, you brought it up, but then you pivoted. You brought up the instant finality earlier, and I think Brandon was trying to follow up on that.
Yeah, so I brought it up in the context of latency. It's a question of what people care about. So often, especially on EOS, you get a transaction in a block. Maybe you have one block building on top of it within a second, basically. You're pretty confident it's going to stay. I mean, maybe you don't want to just wait for one confirmation, because if it's at the end of a producer handoff, there might be some micro forks there and they lose the block. But you wait a second to get 2 blocks. It's, I don't know how many nines confidence you should have, but you're pretty confident it's going to stay there. But if you're really concerned, it's a high value transaction, you really want to wait until it's irreversible. There's algorithmic finality here. Wait, when it's done, it's confirmed, and the network should never fork that. Otherwise, that's a failure in consensus. Basically, that shouldn't happen. So those are basically the 2 milestones you can wait for. You can either wait, a few blocks, depending on your comfort level, very fast, basically instant. It's not technically final, but you're pretty confident it's going to stay there. Or if you're paranoid about it, wait until finality. On EOS right now, the current algorithm, it depends on the number of block producers. Well, so on EOS with 21 block producers, it's about 3 minutes that you have to wait, the time to finality.
Let me add a caveat to that.
Yeah.
So true finality, 3 minutes, but like 98% finality after, I forget.
Probably higher.
Yeah, probably higher than that. Yes.
It's like 99
point something
after, like
after 1 block.
I forget how many seconds, but yeah, I just want to clarify that.
Yep.
Thank you. Continue.
Yeah.
Sorry.
It's important to clarify. I was trying to like, that's the whole thing of what I was saying. Wait a couple blocks, you're good. But some people really care. I mean, I don't know. It's a very high value transaction. Maybe it's worth waiting for that true finality number. So everything that builds on top of that, EVM is no exception, inherits the finality of its underlying layer, right? So that 99.9 whatever percentage confidence you have within a couple seconds that your transaction is not going to be reverted, the EVM transactions inherit that because they're on EOS. Now, same is true for the other number as well, right? If you really, really care about true finality, you're being extra conservative here and you really want to wait for finality, you inherit the EOS time to finality, which again, currently is 3 minutes. With instant finality, that becomes, a few seconds. I don't know what the actual number is. We'll see if the benchmarks, the current numbers show it's going to be low single digit seconds. So then basically it collapses more or less the 99%, whatever number that people mostly rely on now, and the true finality number are basically going to be more or less collapsed. And you could just continue with what you're expecting, that after a few seconds it's final, except now it's actually truly final.
So the instant finality, the reason the Origin team is doing it is because it's directly correlated with IBC. Those high value transactions you're talking about, whenever you're transacting across chains, you need to be 100% certain that things won't get reversed, because it's essentially bridging tokens in a lot of cases. You could use the IBC for any type of messaging, but tokens are the ones that most people relate to. So in that case, like with the current IBC, they're using the 3-minute finality because it's
more than that, right? So it's being extra cautious, partly for the true finality, even though it's very unlikely to revert, because if it did revert, it's a whole complicated process. How would you untangle that mess across two different chains? But it's more than that, because you don't really know, the other chain doesn't really know what's happening on the source chain, right? It's relying on this header validation to figure out what the truth is of what occurred. And you want to have higher security there. You want to have more attestations of what happened. So even though, it's a different kind of trust model, right? Because if you're a full node processing a blockchain, you know the blockchain's valid. So the only question is it going to become final? And you have maybe one or two producers signing off, attesting, yes, I commit to making this final, but you don't have the remaining 13 or whatever that you need. In the case of a IBC, it's more than that, because you only have two producers signing off that this blockchain is going to become final, they think, but also that it's valid. So it's serving a double role there, which means it's really critical to actually get the proper threshold that you need before you actually act on it. I don't know why I went to IBC. This is the thing. Well,
I think we have a little text chat going here, and you brought up IBC, or you brought up instant finality as part of your answer, and the real question was, once the instant finality is deployed, does it have any direct benefits to the EVM? Would it be noticeable to developers, to infrastructure providers, or to anyone? Like, does it benefit EVM specifically?
So it inherits the underlying properties of the chain, both in terms of performance and latency and all this stuff. So for those people who really wanted true finality for their EVM transactions, they see a reduction from EOS's current number down to.
Yeah. Would that have impact on the trustless bridging? So whenever you send EOS and wrap it on EVM, is it near instant?
It doesn't. That's actually truly instant.
Atomic.
Those are these. In IBC, there are two independent chains that we're trying to connect them, weave them together. In the case of how we built EVM, it's riding on top of the EOS chain, and because of that, the interactions between them are immediate, and in fact can happen within a single atomic transaction.
I still need to figure out the best way to articulate the EVM, because it's not a layer 2. You might be able to get away with calling it that, but it's not. It's like how would you guys describe that? It's like a runtime within a runtime. I don't know.
One chain, two runtimes.
Yeah,
maybe.
I'm trying to come up with a good analogy of like a game emulator. So like you think of EOS, it's like a PS5, and you could obviously like emulate like Super Nintendo on it, and running the EVM inside it. It's just like we have this supercomputer called EOS, and we could run other runtimes in it, and performance isn't an issue because the layer 1 is just so damn performant that it could handle any runtime that we throw at it.
I think it's a good analogy.
Yep.
Let's keep it then. One of the things we missed earlier, and it kind of ties in since I just brought up bridging before we wrap up here, is the functionality of the native bridge. One of the features that I thought was really important was one of the points of friction. There's been a couple of points of friction within EOS since the beginning that we're working on through the coalition, through the NF, as far as native EOS, and that's account creation. So on native EOS, you need EOS to create your account. And if you're a new user, you don't have EOS. So it's like a chicken and egg when you buy EOS from an exchange and you want to bring it on chain to create your account. It's a little bit different than what people are used to. So one of the most important things I think of this bridge functionality is that we built it in a way that allows you to just totally skip touching native EOS or a native EOS wallet at all, because you're able to just withdraw tokens from a centralized exchange straight to the EVM. Do either of you guys want to elaborate on how that actually happens?
Sure. Yeah, so that was a very important goal with this bridge, because we really want to make it seamless for someone. It kind of goes back to compatibility of expectations, right? Like someone expects to go on their exchange, withdraw the token of interest, maybe it's ETH if they're going to the Ethereum blockchain, but in this case it's EOS. But they want to withdraw it directly to their accounts that they created in MetaMask for free without having to create an EOS account and pay for that cost, right? So the Ethereum side, this is like straightforward. You just pay the gas to cover the cost, because there's always costs. There's costs on EOS to create an account. There's costs on Ethereum to effectively create an account by sending tokens to it, and the cost is paid for in gas. So there are more advanced mechanisms that can come later post MVP for people who want to kind of pay for the actual gas costs and not anymore. But for convenience, what we built for MVP is the seamless transfer where you can send your EOS directly to your EVM account by providing the EVM address as the memo. But there are gas costs with that. So remember here, there's two computational costs in the case of this ingress, this transfer of EOS into the EVM environment. One is the EOS computational cost of CPU and net, which the exchange is already covering, right? Whether you're sending that to your EOS account or you're sending that to your EVM account, it's a transaction, an envelope transaction that's as CPU and net. They have to pay in, that you pay through power up, essentially. The exchange is covering that. But because its destination is an EVM account, there's an additional EVM gas cost that's there that the exchange knows nothing about, right? They don't know where they're sending it to. They're just sending it to an account name with a memo. It's the same interface they're used to. So we need to cover that cost somehow. And so what we've done is we've added this bridge fee, basically, on incoming transfers, on ingress transfers, where we are going to charge some configurable amount from the transfer amount to cover the gas cost that the EVM contract is going to cover for itself to make that receipt of funds occur.
Yeah, so the whole friction with an EOS account, it's being worked on, but this is like a very short-term solution that literally April 14th, you'll now be able to withdraw EOS from any centralized exchange to an EVM account by simply putting an Ethereum public key in your memo and sending it to a privileged account. I don't know if the account name's been determined yet, but EOSIO dot something owned by the block producers.
EOSIO the EVM.
Yep.
I said it's not privileged, but so I mean, privileged. This privilege has a specific meaning in Antelope. The system contract, the account on the EOSI account is privileged. It allows it to, for example, if you want to deposit, actually pull funds from your account. The EVM contract is not privileged, meaning that in theory, someone else could have, so anyone could actually launch this on their own account as a separate EVM runtime. But it's privileged in the sense where it's sort of special in the same sense that, say, the EOSIO token contract is special, where we're going to create a name, the reserved name, EOSIO dot, in this case, EOSIO.EVM, to host the contract, and it's going to be ultimately owned by the block producers, just like any of the other EOSIO accounts.
Yeah, I mentioned the friction that we're solving for with EOS EVM. The other one's resources. So EOS has a unique model with the power up and the staking for resources that we previously had, whereas the current Web3 users, as the space stands today, most people are used to paying a gas fee for transactions. It's really just another opportunity to meet people where they're at. This is what they're used to. We're giving them what they're already used to. They're going to be able to transact on EOS via the EVM runtime using the public-private keys that they're used to, using the gas fee models that they're used to. Everything is going to be exactly what they're used to. And we get to benefit. One of EOS's strongest superpowers is the fact that it came out in 2017 at a great time, has over 300 exchange listings, and we're able to leverage all of that for the EVM. Whereas if we went the original route with the external token and the external team and all of that, they would have had to have started from ground zero with the exchange listings. And from what I understand, it's very difficult to get tokens listed on new exchanges. So we avoid all of that and get to leverage one of the EOS superpowers.
This has been extremely informative, at times daunting to try and comprehend and follow, but it was very, very good to learn more about the EOS EVM. Thanks so much, Matias and Areg and Zack, for shedding some more light on this exciting development. If folks, thanks for being here. See you again sometime.
I hope everyone watching or listening got a lot of value out of this. I think we packed as much information as we possibly could in an hour or so of your time. If any on enterprising developers are listening, please look into the direct grant framework, or a new season of Pomelo has just begun. EOS EVM projects are eligible for all of the same funding resources that are available to building on native EOS. A grant was recently approved for the EVM name service. TrustSwap has also received a grant. So looking forward to seeing more EVM projects applying through the direct grant framework and applying through Pomelo. So that's my call to action.
Until next time, we'll see you on the next Everything EOS podcast. Thanks for tuning in, and share your comments below. Share your thoughts below in the comments, and we'll do it again sometime. Adios.
All right.
All right.